All right, so what do I have to do for this rational equation to solve it? What did we do yesterday? Well, if the 1 wasn't there, we would just cross multiply, right? But there's a 1 there, so what do I have to do? Yeah, I got to multiply everything by x minus 5. The whole thing. That way we'll get rid of these denominators. So we won't have fractions then. So we want to get rid of the fractions right away when we do these types of problems. So what's x minus 5 times 1? X minus 5, right? Now, when I multiply x minus 5 times this fraction, what happens to the x minus 5? They cancel, so all I have is the x left. And then, same thing happens on the other side. When I multiply this x minus 5 times this fraction, the x minus 5's cancel, all I have is 5. So that's all we have after we do that multiplication. Questions? All right, so when we have these fraction ones, they call them rational equations. We multiply everything, the whole equation, both sides of it, by whatever the common denominator is. Sometimes there's more than one denominator, sometimes we have to write both of them if we can't factor them in and stuff like that. So combining like terms, I get 2x minus 5 equals 5. Add 5, so I get 2x equals 10, and divide by 2, and what do we get? 5. So, is that my answer? Yeah, then why are you shaking your head now?
I feel like that's the right way.
Well, all it works right,
No, I don't do the negative number.
but who said that, Bill?
Yeah.
Go say that again.
Just plug in 5 for x, so it'll be 0 on the denominator.
Right, we're supposed to check, remember? And put it in here. And everything's good unless it equals what? 0. What happened this time? It equals 0. So it's no solution. So we always have to check whatever we get and make sure we don't get 0 in a denominator. All right? If we get a 0 in a denominator like we did here, then that's the only answer we got, and it doesn't work, so no solution. All right? So sometimes that will happen to us. So we did 3 to 24. Number 3 was 2 and plus or minus 1. At a degree of 3, that's why there's 3 answers. Thank you. Number 6 has a degree of 4, but there's only 3 answers because 0 works twice. So it's 0 and plus or minus 6. Number 9 is 0 and plus or minus 4. So 0 works twice for that one. And the number 12 is negative 2, and then 1 plus I radical 3 and 1 minus I radical 3. It's a sum of cubes, so we had to factor it as one of those binomial, trinomial. Any of those you want me to go over? So that was x cubed plus 8. So whenever any exponent that's a multiple of 3 is a perfect cube, and 8's a perfect cube. What's the cube root of 8? 2. All right, so my binomial part is taking the cube root of both of those, so that's x plus 2. And then my trinomial part, and again, this was equal to 0, right? My trinomial part is taking the first term of the binomial and squaring it. X times x is x squared. Since this is addition in the binomial, the middle term of my trinomial is the opposite, so that's minus. And then I just multiply those. X times 2 is 2x. The third term is always addition of the trinomial, and I square the second term. 2 squared is 4. All right, so that's the factored part. All right, once we get it factored, we set the factors equal to 0 to finish it up. Most of you don't need to do this part for this one. You guys all know the answer is what? -2, right? That's a quadratic. That won't factor any further. So you need to use the quadratic formula to solve that one, like we did last week. So we go x equals negative b plus or minus b squared minus 4 times a times c all over 2 times a. All right, so this substituting into the quadratic formula. So we get a positive 2 plus or minus. The denominator becomes 2. And then this square root, negative 2 squared is a positive 4. Negative 4 times 1 is negative 4 times a positive 4 is negative 16. So that's a negative 12. So I have this. Well, do your factor tree. What can I pull out of there? The 2, what else? And the I, right? The 2 for the 4, the I for the negative, and then square root of 3. Is that fraction in lowest terms? No, because what goes into all three of those? 2, right? So I'm going to divide all those by 2 to finish it up. That's a 1 plus or minus 1i, or just I, radical 3, over 1. So you don't have to put over 1. So there's the other 2 answers. Okay? Anything else on the factoring ones, the polynomials? Okay? The rest of them were fraction ones. Number 15 is 2. That's a proportion, so you can just cross multiply there. 18 comes out to be 7. That one you have to multiply by the 2 denominators. You can't factor either one, so your common denominator is 2m plus 1 and m minus 2. When you do that, you'll get rid of your fraction. 21 is 7 halves, or 3.5. Multiply everything by x minus 3 and x minus 2, the 2 denominators you saw. Then 24 comes out to be 35. You just cross multiply that one because it's a proportion. Any of those you would like me to go over? All right, so yesterday was polynomial equations and rational equations. Today is radical equations. They got a square root in them. So when we do the radical ones, the ones like this, the first step is to make sure the radical part is isolated. I always just have it on the left like it is here. So that's what we want it to look like. If not, if I've got plus and minus stuff over here, or something out front that I'm multiplying by it, I'm going to take it over to the other side. By either adding, subtracting, multiplying, dividing, whatever I have to do to move those numbers over. So I want the square root part by itself on the left, everything else on the right, like this is. Now, how am I going to get rid of this square root symbol? What do you think? Yeah, square. Last week we had an x squared by itself equals something, right? And we square rooted to get rid of the squared symbol, right? Well, when we have a square root symbol, we're going to square both sides to get rid of that radical sign. So what do I get on the left when I square that? Yeah, the x plus 4. The square root and the square just cancel each other out. And then 3 squared is 9. And and then just solve for x. So once you get rid of the square root, it's usually pretty easy. Now, just like we did last night, we should check our answer. What numbers don't we like under here? What?
Negative.
Yeah, negatives. So as long as when I substitute x and I get 0 or a positive number, it's a good answer. If I put a number in for x and I get a negative under the radical, then it's not a good answer. Okay? So always check your solution. So 5 plus 4 is okay, right? That's 9 under there. Now what is the square root of 9? 3, so it works, right? Questions on that? Easy stuff, right? Okay, so this one, the radical's on the right, so I'm just going to leave it there. I usually like to have it on the left. But I got to get this 2 over to the other side. So how do I move it? Subtract it, right? Just like normal stuff. We're going to subtract the 2. So I have x minus 2, and then I have the radical isolated here. Now I'm going to do what to both sides? I want to square both sides. Now, how do I square a binomial? How do I square x minus 2? Or what, x minus 2 squared means what? 2 of them, right? How do I multiply something like that? Yeah, we got to FOIL. Okay? So, first, outside, inside, last. So you get x squared minus 4x plus 4. Okay? Here's a shortcut if you want to do the shortcut. Square the x, multiply those two together, which is negative 2x, and then just double it. It's always going to be doubled. So what's negative 2x doubled? Negative 4x, which we got, because there's always going to be 2 of them. And then square negative 2, which is positive 4. So if you want to do that shortcut and not write it out like that, you can. All right, so again, square the first term, the x, multiply the 2 together, negative 2x, and then times 2, double it. That's how the negative 4x shows up. And then it's always plus, because it's a negative times a negative or a positive times a positive. 2 times 2 is 4. Now, what do I have to do now? What kind of equation is it now? Got an x squared in it. What did we call those last week? We had a formula we just used. And the one I did. Yeah, it's a quadratic, right? So what we have to do, since it's a quadratic, is set it equal to what? 0. Yeah. So we're going to have to subtract the 2 and add the x. So it's equal to 0. So I have x squared minus 3x plus 2. All right. If you can factor it, go ahead. If you can't, you can always use the quadratic formula. All right. Are there factors of positive 2 that add up to negative 3?
Yes.
Yeah, what are they?
Negative 2 is negative 1.
Right. All right. So what are my two answers? What's, right, thank you. You guys are quiet today. Now, what am I supposed to do with my answers? plug them into the original problem, right? Make sure I don't get any negatives under there. So, what's 2 minus 2? 0. All right? So, there's 2 equal 2 plus, what's the square root of 0? 0. Is that true? Yeah, so 2 works. Let's try 1. What's 2 minus 1? 1. What's the square root of 1? 1. Is that a true statement? No. So that one didn't work. It was okay, we got a positive number, but when we actually checked the work, it didn't give us a true statement. So the 1 wasn't a good answer. So sometimes that'll happen. Sometimes both work, but sometimes only one of the two work. All right, so in this situation, we had to get the 2 to the other side, so the square root part or the radical part was by itself. Then I squared both sides, ended up getting a quadratic equation and solved it. All right, sometimes you get this kind, where you have 2 radicals. All right, so the first thing you want to do is get one of them alone. So which one is probably easier to get alone right now? Right, the x plus 1. So how do I get it alone? How do I move that one over there? Add it over, right? We good on that? Okay, so now we'll have x plus 1 on the left, square root of x plus 1. And then 1 plus the square root of 2x minus 5. So how do I get rid of this first radical on the left? What have we been doing? Squaring it, right? So I'm going to square, then I'm going to square this too. All right, so that's going to get kind of a little bit of work we're going to have to do on the right. On the left, it's just what? X plus 1. That's easy, right? On the right means this, 1 plus times 1 plus, right? All right, we can do the shortcut if you want. Okay? What do you do for the shortcut? Square that. What's 1 squared? 1. The middle is what do you do with those two? Multiply. What's 1 times that? The square root of 2x minus 5. Then what? Times 2. So that would be 2 of those, right? And then you square this. Well, what's the square root of 2x minus 5 squared? 2x minus 5. Okay? So if I FOIL it, I get outside one of these, inside one of these. When I add them together, I got 2 of them. Okay, so I just like to do the shortcut. Makes it a little quicker for you. Now, I still have a radical. So what should I do? I'm going to get rid of that radical. How do I get rid of this radical? Square. Square, but before I square it, I got to get stuff on the other side, right? All right, so how do I move the 1? Subtract. How do I move the 2x? How do I move the 5? I just put the plus 5 here too. So that's gone, and that's gone. You with me? And like terms, what happens to the 1s? Cancel. What's x minus 2x? Negative x. And then there's the plus 5. It's in there. And then I have this. Okay? So, what's easier, don't take the 2 over. Just square both sides now. All right, what's 2 squared? 4. What's the square root of 2x minus 5 squared? 2x minus 5. So I'm going to do what with that 4 and the 2x minus 5? Yeah, I'm going to distribute. Okay, so there's a lot of algebra you have to do in this one. Over here, let's do the shortcut. What's negative x times negative x? X squared, still positive, right? What's negative x times 5? Negative 5x. Doubled. And then what's 5 squared? 25, right? I should have put it down here. All right, so I got this. Now, I got this x squared, so it's a quadratic again. So I got to set it equal to what? 0. So I got to bring the 8x and the 20 over, so I have 0 on the right. And that's what, a 45 and a negative 18. Are there factors of 45 that add up to negative 18? There are. Who can find?
Not me.
3 and 1. 15. Right? 3 times 15 is 45. And 3 plus 15 is 18, right? So what are my 2 answers? All right. Now we got to go back where? Back to the original problem, right? So we had 3, we had 15. All right, what's 3 plus 1? 4. What's the square root of 4? 2. 2 times 3, 6 minus 5, 1. What's the square root of 1? 1. Is that true? Yeah, so that works, right? 3 is okay. What's 15 plus 1? What's the square root of 16? 4. What's 2 times 15 minus 5? Square root 5. Does that equal 1? No, that gives you negative 1, right? So that one wasn't a good answer. That's a tough one. That has some work to it when you have 2 of them. Griffin? Again, it's not stuff you can't handle. It just takes some time. You guys know how to FOIL. You know how to distribute. You know how to get stuff by itself. Okay? Questions? All right, we good on the square root ones, the radical ones? No questions? All right. The other ones we have today are really easy. Okay? When you look at them at first, they look like they're going to be really hard, but they're not. They're really easy. Okay, Gavin? So, what do you think we have to do to start?
Whatever that is, explode that is.
We're going to do that at the end. We don't want to do that first. Yeah, just add the 5, just like normal. Just pretend there's nothing there for an exponent when you start, okay? So we're going to add the 5.
Divide by 3.
Divide by 3, good. So we want to get the x alone. We want it to look like that. Okay, so, all right. So, when we do a normal equation without any exponent there, what is the exponent? We just never write it. It's 1, right? It's x to the first. You guys all agree with me? Right? We just never write x to the first. We just write x. Okay? So, how do I change 2/5 to 1? What do I do to it? Yeah, the reciprocal, right? So what we're going to do at this point is we're going to raise it to the reciprocal power. What you do to one side?
Not to the other.
Got to do the other. So in your calculator, it's going to look like this. 9 caret parenthesis 5 divided by 2. Okay? All right? So I'm going to go 9 caret and then parenthesis 5 divided by 2. So it looks like that. And then whatever you get, your answer. So you're going to use your calculator.
Oh, wow.
So 243. Yeah. Yeah. So, adding 5 dividing by 3 is nothing new, right? So you get it, x to some power, whatever fraction it is, and then just raise whatever's on the other side to its reciprocal power. Most of these will end up being a whole number like that. Yeah, but always write when you put it in your calculator, put it as a fraction. Yeah. Is that what you were in? Yeah. I would use the fraction. Okay, so this one, what are we going to do first? Oh, I forgot something too. All right. If the exponent is even, and what you look at for even or odd is the numerator. So was this one even? Yeah. When the exponent's even, you have to put this symbol in front of your answer. When it's an odd one, like this one, you don't have to put that symbol. Okay? Yeah, I forgot about that little detail. So for the first one, we got to put plus or minus 243. For this one, we just going to have our one answer. So we subtract the 4. Divide by the 5. Again, stuff you're used to doing. So x is going to be 8 to what power? 4/3, yeah. All right. So 8 caret parenthesis 4 divided by 3, close it up. And we get 16. We don't have to put the plus or minus in this one because my numerator was odd. Okay, only do the plus or minus when your numerator of your exponent is even. Okay? So they kind of look weird at first, but they're really pretty easy. Mm-hmm. Any questions? So today, radical equations, and they call these rational exponent equations because the exponents are rational numbers or fractions. All right? You guys got it? Look good, feel good? You are good? Thank you, Nathan. You guys gotta wake up a little bit. Alright, there's your assignment. It's the radical problems and the fractions for exponent problems. Simple.
What was this one, guys? Was that?
Yes, you can. You're welcome.